Implementation of AI-driven economic models in Davos 2025. Event overview. The implementation of AI-driven economic models at the Davos Economic Forum in 2025 marks a pivotal moment in the intersection of technology and policy. This initiative is structured into 4 critical phases with a dedicated budget of $3 million allocated for pilot programs that will commence in November 2025. The overarching goal is to leverage advanced AI technologies to enhance economic decision-making processes, reflecting a broader trend of integrating artificial intelligence across various sectors. Phased implementation. 1. Research and Development Phase 2024 to 2025. The first phase involves extensive research and development to align AI models with current economic challenges. This phase will focus on understanding the complexities of economic data and identifying key areas where AI can add value. Stakeholders, including economists, data scientists, and policymakers, will collaborate to create foundational models that can be tested later. 2. Pilot Testing Phase November 2025. The pilot programs will be officially launched in November 2025 utilizing the allocated $3 million budget. These pilots will test various AI-driven economic models in real-world scenarios, allowing for practical insights into their effectiveness. The initiatives will aim to resolve specific economic issues such as fluctuations in market trends and resource allocation inefficiencies. 3. Evaluation Phase. Following the pilot tests, a comprehensive evaluation phase will assess the performance of the implemented models. This will involve analyzing data collected during the pilot programs to measure success against predetermined metrics. Stakeholders will provide feedback on the AI tool's effectiveness, leading to refinements and adjustments. 4. Scaling successful models. The final phase will focus on the scaling of successful AI-driven economic models. Insights gained from the evaluations will inform broader implementation strategies across various sectors. This phase aims to integrate successful models into mainstream economic practices, further enhancing the decision-making capabilities of policymakers and business leaders. Budget allocation. The $3 million budget allocated for pilot programs signifies a substantial commitment to experimenting with AI applications in economic contexts. This funding will cover development costs for AI technology and tools, resources for data collection and analysis, engagement with experts and stakeholders for effective implementation. By prioritizing these areas, the initiative aims to foster innovative solutions that can adapt to the rapidly changing economic landscape. Use cases for AI in economic modeling. Potential use cases for AI-driven economic modeling include predictive analytics for market trends. AI can analyze historical data to forecast future market movements, enabling businesses and policymakers to make informed decisions. Optimization of resource allocation. AI algorithms can identify the most efficient ways to allocate resources, minimizing waste and maximizing productivity. Simulation of economic scenarios. AI can simulate various economic scenarios based on different policy decisions, allowing stakeholders to understand potential outcomes and impacts before implementation. These use cases highlight the transformative potential of AI in enhancing economic frameworks, providing stakeholders with tools to navigate uncertainties effectively. Common themes across sources. All sources emphasize the increasing significance of AI in economic frameworks, underscoring a shift towards data-driven decision-making. The focus on pilot programs indicates a cautious yet optimistic approach to adopting AI technologies, allowing for iterative learning and adjustments based on real-world applications. The collaborative nature of the initiative also reflects the need for diverse perspectives in developing effective economic models. Differences in perspectives. While some sources emphasize the technical aspects and potential challenges of integrating AI, others may focus on the economic implications and broader societal impacts. This divergence illustrates varying priorities among stakeholders from technologists to policymakers. For instance, technologists may highlight the complexities of data integration and model accuracy, while policymakers may prioritize the economic benefits and societal implications of AI adoption. Timeline of events: 2024 to 2025, preparatory phases including research and development will align AI models with current economic challenges and opportunities. November 2025, official launch of pilot programs funded by the $3 million budget. Initial testing of AI-driven economic models begins. 2026, evaluation of pilot programs and scaling of successful models based on feedback and data analysis. Conclusion: the initiative to implement AI-driven economic models at Davos represents a significant step towards modernizing economic decision-making processes. By structuring the project into distinct phases and allocating a solid budget, the endeavor aims to harness AI's capabilities to address complex economic issues. The outcomes of the pilot programs will likely inform future strategies for broader AI integration across various sectors, paving the way for a more responsive and adaptive economic landscape. As we move towards 2025, the collaboration between technology and policy will be critical in shaping the future of economic frameworks, ensuring that they are equipped to meet the challenges of an increasingly complex global economy. The implementation of AI-driven economic models at Davos in 2025 presents some counterintuitive information that challenges conventional wisdom surrounding technology integration in economic policymaking. Below are several key points highlighting these counterintuitive elements. 1. Low initial budget for high expectations. Despite the ambitious nature of the project, the initial budget of $3 million allocated for pilot programs may seem surprisingly low when considering the complexity and potential scale of AI-driven economic models. Typically, large-scale technological initiatives command significantly higher investments. This modest budget could imply a cautious approach to innovation, suggesting that stakeholders are aware of the risks and are opting for a phased incremental approach rather than a full-scale rollout. The expectation that such a small budget can lead to significant advancements in economic modeling is counterintuitive, as one might expect that substantial funding is necessary to achieve meaningful results in AI applications. 2. Phased implementation reflecting caution. The structured four-phase implementation plan indicates a cautious attitude towards adopting AI technologies, contrary to the aggressive adoption seen in many sectors. While many organizations rush to integrate AI, often leading to failures or inefficiencies, the phased approach taken here emphasizes learning and adaptation. This is counterintuitive in a landscape where rapid deployment is often equated with innovation. The phased method underlines the importance of ongoing evaluation and adjustment, which could lead to more sustainable outcomes, even if it initially seems slow or conservative. 3. Focus on pilot programs as a learning tool. The emphasis on pilot programs as a primary means to test AI-driven economic models contrasts with the expectation that technology should be deployed at scale from the outset. This approach reflects an understanding that real-world applications often differ significantly from theoretical models. It suggests that stakeholders are prepared to learn from smaller-scale implementations rather than assuming that large-scale deployments will automatically yield positive results. This learning-oriented mindset is counterintuitive in a competitive environment where success is often measured by quick wins and large-scale impacts. 4. Diverse perspectives on economic impact. The divergence of opinions among stakeholders regarding the implications of AI integration presents a complex picture. While some sources focus on the technical challenges and potential failures, others highlight the transformative economic benefits. This contrast suggests that the integration of AI into economic models is not universally perceived as a straightforward improvement. The expectation that a technological advancement will lead to clear economic benefits is complicated by the reality that such integration can also introduce new risks and uncertainties. This nuanced view challenges the simplistic narrative that technology adoption is inherently beneficial. 5. AI as a tool for cautious optimism. The project mirrors a growing trend of cautious optimism towards AI in economic contexts, contrary to the prevailing narrative of disruption and upheaval. The expectation that AI will provide clarity and enhance decision-making is tempered by an acknowledgement of its limitations and the necessity for careful implementation. This perspective challenges the notion that technological advancements will automatically lead to significant improvements, suggesting instead that human oversight and contextual understanding remain crucial in harnessing AI effectively. 6. Complexity of economic indicators. The assumption that AI can easily simplify complex economic indicators is misleading. While AI can enhance data analysis and provide insights, the interpretation of economic data is multifaceted and influenced by numerous variables, including human behavior, policy decisions, and external shocks. The expectation that AI can provide clear. The report on the implementation of AI-driven economic models at Davos in 2025 outlines a structured approach to integrating advanced technology into economic decision-making processes, which is significant for several reasons. Here are the key overlooked aspects of the report and their importance. 1. Phased implementation details. While the report mentions 4 critical phases: research and development, pilot, testing, evaluation, and scaling, many may miss the nuances in how these phases interrelate and inform one another. Each phase is not just a sequential step but represents a learning and feedback loop critical for adaptive management in complex systems. The significance lies in the iterative nature of the project, which allows for adjustments based on real-world data and outcomes. This approach can lead to more robust models that better reflect economic realities, ultimately enhancing the efficacy of policy decisions. 2. Budget allocation insights. The allocation of a $3 million budget is noteworthy, but the underlying strategy behind this financial decision is often overlooked. The budget reflects a deliberate choice to prioritize experimentation and learning over large-scale implementation without prior validation. This cautious approach is significant because it recognizes the challenges of AI integration in economic frameworks, especially given the uncertainty and variability in economic data. It emphasizes a commitment to evidence-based policymaking, which is crucial in avoiding the pitfalls of poorly conceived economic interventions. 3. Use cases and their implications. The potential use cases for AI, such as predictive analytics and simulation of economic scenarios, highlight a shift towards data-driven decision-making. However, the transformative implications of these use cases for traditional economic models are often underappreciated. By integrating AI, stakeholders can uncover patterns and insights that may have previously gone unnoticed, leading to innovative policy solutions. This shift towards a more analytical and evidence-based approach can fundamentally change how economic models are developed and implemented, with far-reaching effects on global economic governance. 4. The importance of pilot programs. The emphasis on pilot programs as a testing ground for AI applications is significant. Many reports may gloss over the role of pilot initiatives in fostering innovation and risk management. These pilots serve as critical experiments that allow stakeholders to assess the feasibility and effectiveness of AI models before wider application. The insights gained from these pilots can inform not only the specific economic models being tested but also broader strategies for AI integration across various sectors. This iterative learning process is essential for building confidence and trust in AI-driven solutions. 5. Common themes versus divergent perspectives. The report notes common themes across sources regarding the growing importance of AI in economic frameworks, yet the divergent perspectives highlight a crucial tension between technologists and policymakers. This tension can lead to friction in implementation, as different stakeholders may prioritize different outcomes. Understanding these varying priorities is significant for fostering collaborative approaches to AI integration. It underscores the necessity for dialogue between technologists who focus on the capabilities of AI and policymakers tasked with navigating the ethical and societal implications of these technologies. 6. Societal implications of AI integration. While the report primarily focuses on economic implications, the broader societal impacts of AI-driven models are often overlooked. The integration of AI into economic decision-making processes can affect labor markets, social equity, and public trust in institutions. These societal dimensions are critical for assessing the long-term viability of AI applications. Policymakers must consider not only the economic outcomes but also how these technologies will shape societal structures and relationships. Ensuring that AI serves as a tool for inclusive growth rather than exacerbating existing inequalities. 7. Long-term vision beyond Davos. The report's focus on the short-term pilot programs may obscure a longer-term vision for AI integration in economic models. Stakeholders need to recognize that the outcomes of these pilots will likely serve as a foundation for future innovations. The significance lies in the potential for these efforts to influence global economic governance structures and practices beyond 2025, shaping how economies adapt to complex challenges in the future. In conclusion, the implementation of AI-driven economic models at Davos in 2025 reflects a significant evolution in economic decision-making. By focusing on the overlooked aspects of phased implementation, budget strategies, use cases, pilot programs, stakeholder perspectives, societal implications, and long-term visions, stakeholders can better understand the potential and challenges of integrating AI into economic frameworks. This comprehensive approach is essential for ensuring that AI technologies are harnessed effectively to address complex economic issues and foster sustainable growth in an increasingly interconnected world. 1. Phased implementation. The initiative is structured into 4 distinct phases, each with a specific focus on different aspects of integrating AI into economic models. This phased approach allows for a systematic and organized rollout, addressing potential challenges at each step and refining the models based on feedback and real-world application. The phases likely encompass research and development, where foundational AI models are created, pilot testing, where these models are tested in controlled environments, evaluation, where the effectiveness of the models is assessed, and scaling, where successful models are expanded for broader use. This structure emphasizes a methodical approach to innovation, ensuring that the integration of AI is not only effective but also sustainable in the long term. 2. Budget allocation. With a dedicated budget of $3 million earmarked for pilot programs, there is a clear commitment to exploring the practical applications of AI in economic contexts. This funding will support the development of AI tools that can analyze complex economic data, enhancing policy decision-making processes. The allocation signifies an important investment in technology that aims to modernize economic frameworks at Davos, reflecting a recognition of the increasing importance of data-driven insights in economic strategy. Furthermore, the budget indicates a willingness to experiment and learn from these pilot programs, which could lead to significant advancements in how economic models are constructed and utilized. 3. Use cases. The potential applications of AI in economic modeling are extensive and include predictive analytics for market trends, optimization of resource allocation, and scenario simulation for policy impacts. By leveraging AI, stakeholders can gain deeper insights into complex economic indicators, which can lead to more informed decision-making. These use cases underscore the transformative potential of AI in enhancing the accuracy and efficiency of economic modeling, allowing for a more responsive and adaptive economic framework. As these applications are tested in the pilot programs, they may uncover new methodologies for economic analysis that could revolutionize the field. 4. Common themes across sources. A consensus among various sources highlights the growing importance of integrating AI into economic frameworks, marking a significant shift towards data-driven decision-making. The emphasis on pilot programs reflects a cautious yet optimistic approach, allowing stakeholders to learn and adapt through real-world applications. This iterative approach not only mitigates risks associated with new technology adoption but also fosters a culture of continuous improvement. As the pilot programs progress, the insights gained will be crucial in shaping future strategies for broader AI integration across different economic sectors, ultimately aiming to enhance overall economic resilience and adaptability in the face of evolving challenges. 1. The Enron Scandal 2001. The Enron scandal is a notable case of corporate fraud that resulted in the collapse of the Enron Corporation, an American energy company. Enron's executives used accounting loopholes and special-purpose entities to hide debt and inflate profits. The scandal led to significant regulatory reforms in the accounting industry, including the Sarbanes-Oxley Act of 2002. The case illustrates how the lack of transparency in financial practices can lead to catastrophic consequences similar to concerns regarding ethical AI implementation in economic models. 2. The 2008 financial crisis. This global financial crisis was precipitated by the collapse of the housing bubble in the United States, leading to widespread failures of financial institutions. Complex financial products, including mortgage-backed securities and derivatives, obscured the true risk levels. The crisis underscored the need for better regulatory frameworks and highlighted the importance of transparency and accountability in financial markets. The integration of AI in economic models as proposed for Davos 2025 must be guided by lessons learned from this crisis to avoid similar pitfalls. 3. The Volkswagen emissions scandal 2015. Volkswagen was found to have installed software in its vehicles to cheat emissions tests, resulting in vehicles that emitted pollutants far above legal limits. The scandal had significant financial and reputational repercussions for the company and led to increased scrutiny of corporate governance and compliance practices. This case emphasizes the ethical challenges and potential for misuse of technology, paralleling concerns about the responsible use of AI in economic modeling and decision-making processes. These historical cases highlight the importance of transparency, ethical practices, and regulatory oversight in the implementation of complex systems akin to the AI-driven economic models proposed for Davos 2025. Future outlook: AI-driven economic models in Davos 2025. The implementation of AI-driven economic models at Davos in 2025 is poised to revolutionize economic decision-making. With a structured approach involving 4 critical phases and a budget allocation of $3 million for pilot programs starting in November 2025, several predictions can be made about the implementation and impact of this initiative. 1. Enhanced decision-making processes. Prediction: by integrating AI technology, economic decision-making will become significantly more efficient and accurate. The predictive analytics capabilities of AI are expected to provide real-time insights into market trends, enabling stakeholders to make informed decisions based on data rather than intuition. Impact: policymakers and business leaders will rely increasingly on AI-generated forecasts, leading to more effective resource allocation and strategic planning. This shift will foster an environment where decisions can adapt quickly to changing economic conditions. 2. Iterative learning and model refinement. Prediction: the phased implementation will allow for iterative learning, where feedback from pilot programs will inform adjustments and enhancements to the AI models. The initial pilot programs will serve as a testing ground for various economic scenarios. Impact: this approach will lead to the continuous improvement of AI models, making them more robust and better suited to the dynamic economic landscape. Over time, the models will evolve, incorporating new data and insights, resulting in increasingly precise economic predictions. 3. Increased collaboration across sectors. Prediction: the initiative will catalyze collaboration among various stakeholders, including governments, businesses, and academia. The integration of AI in economic models will encourage partnerships to develop innovative solutions for complex economic challenges. Impact: collaborative efforts will lead to the sharing of best practices and technologies, fostering a culture of innovation. This synergy may result in the development of new AI applications that extend beyond economic modeling, impacting sectors like healthcare, education, and infrastructure. 4. Societal implications and ethical considerations. Prediction: as AI-driven economic models gain prominence, discussions around ethical considerations and societal implications will intensify. Stakeholders will need to address issues related to data privacy, algorithmic bias, and the potential displacement of jobs. Impact: the heightened focus on ethics will lead to the establishment of guidelines and regulations governing AI use in economic contexts. Stakeholders will be compelled to ensure transparency in AI decision-making processes. Fostering public trust in AI technologies. Conclusion: the future of AI-driven economic models at Davos in 2025 promises transformative changes in decision-making processes, collaboration, and ethical considerations. As the initiative unfolds, the lessons learned from pilot programs will not only shape economic policy but also influence broader societal norms and expectations regarding the use of AI. With a dedicated budget and a phased implementation strategy, the groundwork is being laid for a future where AI plays a central role in shaping economic landscapes globally.